let's go over the architecture of the ton pool solution, and just to give you guys some overview to get started. A nominator or staker will use the Chorus1 SDK to stake to one of our two pool contracts. These contracts are managed by a controller that also controls a validator node running in our infrastructure. The part you guys will be interested in are these 4 contracts here. This is our pools. We have 2 of them, and each of them have a proxy contract. When there's an election, the controller will send a message to the pool. The pool will then forward the same message to the elector's contract down here, and that is how we get our validator elected and actually join the validation round. The elector contract is on the master chain, and that's a part of the ton system itself. Our proxy is deployed also on the master chain because the elector requires all messages sent to it to be from the master chain. And lastly, our pool is deployed on the work chain because the work chain has much lower gas fees than the master chain. We have 4 main workflows for this contract. The first one is stake. A nominator wants to stake. They use our SDK or staking front end to send their stake to one of the pools. At the start of the next election round, our controller will accept the stake, and from then on, the stake will be active, and we will start earning rewards. Unstaking is a 2-part process. The first part, at least seen from the nominator side, is they send an unstake message to our pool. That will put the unstake in a pending state. The next time there is a new election, our controller will accept this withdrawal, and after that, the nominator can send a new withdrawal message to get their funds back. Next, we have a stake submission, also known as send stake in Ton. The controller is responsible for initiating this. It sends a send stake message to our queue. The queue sends it to proxy. Proxy sends it to the elector. The elector then decides if the amount of ton we sent in is an acceptable amount or not. If it is, it will accept our bid and send a message back that says that it accepted our election bid. Then we have stake retrieval or recover stake, which is also known as. Our controller will send a recover stake message to our pool, which forwards to the proxy, then to the elector. If everything goes well, the elector should send our stake plus any rewards we earned during the previous validation round back to us via the proxy. That's it for this. In the next video, we'll go through code. All right, let's get through the code, or at least do an overview. There are 2 contracts that are part of this work. The first one is the proxy, which is quite short. We'll not review that now. We'll take a look at the nominator's contract, which is where the main part of Ton Pool lives. This contract has 2 entry points. One, receive external, which always throws an error because we're not interested in external messages. We're only interested in internal messages. So this entry point handles everything for this contract. And there are 4 entities that can send in messages. We have the controller, the elector contract, the owner of the contract, and nominators, everyone that wants to stake with us. One thing to bear in mind here, this loads data when it starts, load-based data. That basically loads all the data in the contract into globals. There's another one called store-based data that does the opposite. That's usually called at the end. Just so you know about that. First off, let's go through what the controller can do. So after just parsing the messages and doing some checks, the controller can ask the contract to send stake to the elector or recover stake from the elector. And here we also have accept stakes and accept withdrawals. Those are the main ones that we actually use. Then we have the elector. We need to get some messages back from the elector and handle them correctly. The first if here is handling bounced messages. If any errors at all should happen in the call path when we're, for example, send stake, which includes almost all the time in the contract, we need to make sure that we update our own internal state when we receive such a bounce, so that the contract actually knows that it failed and updates its own internal state. Then some more parsing, and there are basically three messages we are interested in. One is OK stake response, so meaning we got elected. The other is a failed stake response, so we didn't get elected for some reason. And the recover response, when we recover the stake after a successful validation round. Next up is the owner, meaning here in this context, the owner of the contract. After some parsing, we end up looking at the different workflows. One is upgrade. That's to upgrade the contract code if we need to patch or change anything. Then there's the deposits, so the owner can choose to stake, so meaning we can stake with ourselves if we want to. Then there's a withdraw stake, mainly used to withdraw the rewards that I have accrued. There's a safety valve or recover stake. If anything should ever get stuck, the owner can fix that. And then we can change the controller if we should need to do that at any point. And lastly, we have the nominators. So just some message parsing, and then we get down to the workflows they can actually do. We have deposit stake, withdraw stake, and that's the only ones we actually use. That's it. There are a lot more details. This was just intended to give you an overview so you know where to start.